everybody. How's it going? Great. So let's get started. I have a whole lot of ground to cover and not a lot of time to do it. My name's Ernie. I work for Living Social, and I've written a whole bunch of ActiveRecord related gems that you may have used in the past. I've spent a lot of time working on integrating with ActiveRecord in all sorts of ways. I've written Squeal and Ransack and MetaWare and MetaSearch and Valium and a bunch of other gems. As I say, I work for Living Social. We are hiring, and I would certainly recommend you swing by and talk to me either after this talk or sometime for the remainder of this week if you have any interest. This slide is totally not for you. This is my mom. She thinks I'm awesome, psyching me up for the talk. So I don't know how many of you actually read the talk descriptions. The thing about the talk description is at the end there was a very important warning. You may not have been aware, but there is going to be a lot of ActiveRecord source code in this talk. So a lot of it, like seriously a lot. And we're going to be moving very quickly. Things might get a little crazy. In fact, I would go so far as to say that my goal is not so much to teach you about ActiveRecord internals today, but to fit as much crazy as possible into the next 40 minutes or so. So I'm just warning you up front, there is time to escape. If you leave now, I won't be offended. If you leave in like 5 minutes, I'll be a little hurt, but I think I'll get over it. So what is ActiveRecord? Well, it's first off a design pattern, as you're probably aware. Martin Fowler describes it as an object that wraps a row in a database table or view, encapsulates the database access, and adds domain logic on that data. He goes on to emphasize simplicity that is present in the ActiveRecord pattern and how easy it is to understand. ActiveRecord is also a library. There's a simple example of using ActiveRecord, and just has a few attributes, name, email, and the timestamps, ID column, of course. And once you have that model in place, you have 57 ancestors to that model, most of which are modules that get included into the ActiveRecord-based subclass. You get over 500 methods on the class. You get over 300 methods on the instances of that class. ActiveRecord, the library, also has over 15,000, almost 16,000 lines of code. So for comparison again, ActiveRecord has the primary advantage of simplicity. It's easy to build ActiveRecords, and they're easy to understand. So that was the pattern. This is the library. Pattern, library, pattern, library. You get the idea. So I actually caught some flack for spelling ActiveRecord without a space. The official Rails core team approved way of spelling ActiveRecord is ActiveRecord with a space. However, I think you'll have to forgive me for saying that I don't believe that ActiveRecord is the same as ActiveRecord. Now, don't get me wrong, ActiveRecord was one of the first things that I saw in Ruby or Rails, really, that made me go, wow, this is like amazing magic. I don't even know how this works. And it's what sparked my interest in Ruby and Rails initially. How many of you had a similar opinion when you first interacted with ActiveRecord? Right, like almost every hand in the room, right? So I love ActiveRecord, but, and it's a big but, ActiveRecord has issues. It has a lot of issues, in fact. Look at how many issues ActiveRecord has. So you want to hear my theory on this? I have a theory about why ActiveRecord has so many issues. And it's not just the code size. I think it's because nobody understands ActiveRecord. So you get issues that people write that maybe aren't really issues, but they don't understand how the library works. And because nobody understands ActiveRecord, there's nobody that can actually say, hey, this issue is totally bogus. So they sit around. And I know most of you in the room are probably saying, that's darn right. Nobody understands ActiveRecord. I sure am glad I'm the exception. If your face is not up here, you are not the exception. You're not, no. So, and that's forgivable, right? Because here's a comparison of all the various libraries that are part of Rails. Now, I took the liberty of splitting out Action Pack into Action Controller, Action View, and Action Dispatch. ActiveRecord, barring active support, is easily twice or more the code size of just about any other part of Rails, right? In fact, if you throw out active support, it's more than the code size of everything left. So from the documentation for ActiveRecord, one of the design philosophies behind it is magic is not inherently a bad word. I agree. I mean, Magic is not necessarily a bad word. But there's this kind of magic, this dude that you have at your kid's birthday party, and he pulls a rabbit out of the house, and everybody's like, hey, that's awesome. And then there's this kind of magic. If you don't remember this video, I'm going to call this, I struggled for a term for this kind of magic. I'm going to go with douchebag magic. So this is douchebag magic. Douchebag magic takes your delicious orange soda, turns it into Cheetos, and puts this orange soda in your friend's mouth, makes him spit it out. That's what douchebag magic does. It's the unexpected stuff that you're totally surprised and like, how did this even happen? And it's not even for your benefit. So the trick with magic is that it requires conventions, and conventions are going to require opinions. And believe it or not all opinions are created equal. So the thing about it is, you have to make trade-offs whenever you exercise an opinion in something. And those trade-offs are going to determine how other people are going to interact with your library. I have a quick two-step process for how to create a learning curve if you're writing any kind of API. Step 1, find things that your users already understand. Step 2, ignore those things. So for instance, you may think you know how to initialize an object. If you initialize an object that's a subclass of something else, you might be used to saying, I want to provide some defaults to that object. So I'm going to say, if I initialize a user and they don't have a name, then I'm going to go ahead and give name not provided as a value. So that shows up in my view or whatever. And you try it, and it works. You say user.new, and you have name not provided. It's what you expect, right? And then you find it from the database, and you get nil, and you're like, what the heck? As it turns out, this is because the Rails way to handle this kind of thing is to define an after initialized callback. So you learn this as a Rails newbie, and you say, all right, I guess I'll take that. That's what I'll do. And it works. I mean, and it's fine, and it does work. But did you ever wonder why that happens? Well, some trade-offs were made. It has a pretty standard, ActiveRecord base has a pretty standard initialize. I mean, it's kind of long, kind of lengthy, but it does what it needs to do. Right below the initialize method, however, is a method called initWith. INITWith, by the way, has some bonus magic. I don't know if you know this or not, but if you don't, there's some awesome bonus magic that exists in INITWith. If you find a record out of a database and you select additional attributes from the table that you're selecting, your instance of class user in this case can have methods that match the name of the columns that you've just selected. So that actually means you can have two instances of class user that have completely different methods based on what they happen to be selected from, which is fun. The only place that initWith is called in the entirety of ActiveRecord is right here in persistence.rb and instantiate. You can see what we do is we bypass the normal allocate initialize that we would do with a normal call of new against an object. And instead, we allocate and call initWith, and we provide attributes in the column types. Now, an instantiate's called a lot of places, but the most obvious place is inside find by SQL. Whenever you find records, this is how they become hydrated into ActiveRecord objects. It's also used whenever you load associated records from an eager loading query or something like that. So the trick to this stuff is you need to understand enough of the code to see the trade-offs that are being made and then maybe question them. For instance, I wondered what might happen if we had a build method on the class that was for creating new records, and new just behaved like new, and we could just override initialize like we always would. You have to kind of understand the trade-offs they made. You know, certainly .new, the trade-off they made is that they wanted everybody to be able to just create a new object, and automatically it would mean it was an unpersisted object. Cool, fine, whatever. Associations, let's move on. They're totally simple until they're not. And let's take a pop quiz here, actually. Here's a question. Let's say we're developing the next awesome blogging engine because the world needs another one of those. And we define this assign post message in the method. And the intent is that we can assign one or more posts that may already exist to the user. And of course, we don't want to attribute words to some other user that maybe they don't approve of. So we're going to go ahead and make those posts unpublished until some approval process goes through. So we go ahead and add those posts to that individual. And we ask whether or not the user ID of the post matches the user ID of the person. What happens? You have your answer ready? Hope so. The answer is, I have absolutely no idea. I'll give you bonus points if you happen to say I'm not even testing the right attribute. And here's why. Depending on whether or not user is persisted, you may or may not auto-persist the posts at the time that you go ahead and assign things. Now, I understand the intention is, oh, well, it's simpler if something is already persisted to just auto-persist the things that we're adding. But you also don't have a chance to modify those objects once they've been added at that point. And it's inconsistent. The behavior, it's unpredictable. Now you have to know whether or not your user is persisted before you assign something onto it, or else you may save when you're not intending to. So another fun thing about associations is that you can use them in joins, right? And so you're familiar with this syntax probably. We have a posts association and also a publish post that adds some conditions. So of course you can say user joins posts, and you can put some conditions on the post by putting a hash with a hash value inside, and the conditions will be against the post table. And of course then you can join published posts and ask where published posts, right? No, you can't. You can't do that. Why can't you do that? Because of this little guy right here. Predicate builder, whenever you actually build wheres, gets invoked and builds from a hash. When it does that, it actually, at the point of whenever it actually creates the table, it's creating the table from the key. So what you're really saying is, I have to know that my table name is post, which is fine if you only have one join of posts. But if you start to join posts and then maybe publish posts, or you join, maybe you have a parent-child relationship and you're joining children several levels deep. You're joining the people table, let's say, multiple times. Well, ActiveRecord's really cool, and it gives you aliases automatically so that you don't have the query blow up, but you have absolutely no way to know what the table name is up front. So there are ways around this, right? And in fact, in Squeal, I actually defer creating these arrow tables until the time we actually run the query so that later joins or whatever can be considered and we can look things up. But there's drawbacks there, and we'll get into those later. So then maybe you learn that you want to have multiple roles on a post. Maybe you have an author and an editor and I don't know what else, right? So you learn how to do has many through. And so you have this rich join model that has a role, and you validate the presence of that role. Now, of course, right away you say, OK, I'm going to create a new post. And I'm going to set that current user. And it fails. And you say, oh, well, it fails to save. Oh, duh, I have a role, right? I need to put a role in because I'm validating. So then you think, OK, so I've created this post, and this user exists. So if I create the association, then certainly the join model should exist too, because it's eventually getting persisted to the database. And you'd be wrong. It doesn't. And so you finally resort to the most laborious way of doing things, which is building the individual join model first, and then from the join model going ahead and building the post on that, and then saving the join model. I guess, that's OK, but something feels slightly off about that. So then some genius comes along and tells you, hey, you can do this. And you can add additional associations with authors or editors or whatever you want to do with the conditions and create your associations through there, so you can associate those records through that association, and you'll get the required behavior, right? Well, that's great, assuming you know all of the roles that you might want to assign, but what if you want to allow people some flexibility? So most people stop there and they say, oh, that's good enough. I'll deal with that. And yes, I'll have like 20 different macros at the top of my class for every single possible role, but we'll get over it. I got curious about why this was, and I started digging in, and I found that the has many through association, which inherits from the has many association, is not actually creating its own build through record, right? So what I'm doing is I replace a non-existent concat records, which was just using the one from has many associations, and I build the through record. Seems pretty sane, right? So I run the tests, everything passes, and I submit a pull request, and it gets merged, and it gets cherry-picked, and we release 329, and everything is awesome, right? How many people know what happened next? Everything was terrible. So if anybody happened to upgrade to 329, it was if I remember right, it was a security release. And if your association's broke, you can come see me later for a hug. What I learned from this is that the tests lie a lot, and we can't necessarily trust them. Even though all the tests passed, It was an unpleasant experience for a lot of people. So, my bad. Anyway, right, so what I ended up finding out was going on is that a lot of folks were doing their validations like this. So they have validation on the join model, validating those belong-to relationships, validating the ID, right? Okay, fine. So whenever they would go ahead and create the new post, they would add the contributor, they would hit save, and what happens? Nothing, doesn't work. We dig in and we find out that that's because the contribution is not valid. Well, it's not valid because at that point the post has not been saved, so it doesn't have an ID, so we can't set the ID yet. So how many of you know what inverse of does on your associations? Less than I even had hoped for. Okay. So inverse of is the oldest ActiveRecord feature that you aren't using, and you should totally use it, and here's why. So here's an example. User equals users first. All right, so you find the first user. You then find his first contribution. One would think you would compare the first user's first contribution user with the user who owns the contribution, and you would get object equality, right? No, you wouldn't get object equality. That would make sense. So what you actually have going on here is that you've loaded the contribution, the first contribution, and then when you access the user association on that contribution, you're hitting the database. You're round-tripping to the database again, bringing back a brand new instance of user. So the object equality doesn't match. Now, it's pretty easy to fix. This has been around since 4 years ago. It's so awesome, the inverse of option for your association macros. And it actually was so useful that it got backported to 2.3. So if you're one of those people who stopped in Kansas, you can still use inverse of. And here's how it would work, right? So you would, in this particular case, here's your post, here's your user. You describe what they're the inverse of, and whenever you load the association, before the association objects get handed back to you, they have that inverse set to the exact same in-memory instance of the object that we're talking about. So that contribution, when it has many contributions, it's going to have the post or the user get set whenever you load it. And so then you start validating on the presence of the actual object, user and post. And voila, 329 and onward would have worked for you. Now, the thing about that is, and the thing that I think is important about this, I want to stop and give you some deep thoughts on validations for a moment. Now it's time for deep thoughts on validations. Validations live in Ruby. Therefore, they should care about Ruby objects. Association ID is an implementation detail. Nobody in this room needs to worry about that ID. You worry about the presence of the object. In fact, if you start to think about it another way, how do you know the record that you're actually joining to is really present just because it has an ID value? You don't know. Some random gremlin could have come in and deleted that record from the table. You don't know. So your first response to that is going to be, oh, but wait, my raffle scales. What will happen? Because now, every time I save a new record, I'm going to be loading this associated record from the database. That's not OK. Look, your raffle scales are going to be fine. And here's why. For starters, do you write more or do you read more from most databases? You're going to incur a hit every time you validate. That's true. You will load the associated record. But you won't incur that hit every single time you load an association from your associated records. So you say, you know, my user has many posts. You load a post. Now you already have user available to that post without having to round trip to the database again. Trust me, you're going to suffer more pain from that than you're going to suffer from an occasional extra hit to the database on your validation. Plus, you're actually validating things now. Speaking of validations, this is my favorite validation ever. How many people love validates uniqueness of? The thing that I most love about validates uniqueness of is that it actually doesn't, you know, validate uniqueness of. And you don't have to take my word for it. This is, and I actually got a chance to have dinner with DHH last night, and I told him that this is my absolute favorite comment in all of the ActiveRecord source code. This is out of the uniqueness validation comments. Note that it tells you that it doesn't validate uniqueness. It says it in a different way, right, so that you don't notice, but I'm telling you now, it doesn't validate uniqueness. Validates uniqueness of, you had one job. Seriously. So more helpfully, maybe, it does go on to explain that you should probably go ahead and add a unique index to your database table. Now, that's going to end up looking like this. The primary benefit, people would say, is, oh, I get nice validation error messages now. I can say that my email was already taken, right? Here's the thing. Whenever you're doing that, you're running a round trip to the database again to find out whether or not potentially. And this is another one of those things where if you reflect on my deep thoughts on validations, you would say, well, the email shouldn't have any knowledge of whether or not it's unique in a sea of other emails, right? Like, that's the database's job. The database handles relations, and this is just an object. So you're already adding the index there. So here's what you can do instead. If you override save, for instance, you can call super. You can rescue a handy little error that it gets raised specifically if your record is not unique by ActiveRecord. And you can add the same validation error that or validation message that you would normally have, and you don't have to round trip to the database twice to do it. And by the way, it actually works. It does, in fact, validate uniqueness of, which is probably the point to begin with, right? So you say, well, that's great, but what if I have multiple uniqueness constraints, or what if I have a scope, or whatever? Well, got you covered there too. It takes a little more doing. These will all, I'll put all this code up anyway so that you can look at it in more depth. I don't have time to spend too much time on it. Assuming you use Postgres, and you are using Postgres, right? You have a relatively sane error message that comes back whenever you actually run into a uniqueness constraint violation. And you can actually parse that out and see what columns are the problem. So I mentioned a while back that we had some problems with Squeal whenever I was trying to defer handling the association conditions. It's because of this guy right here. How many of you use relation merge? All right, the rest of you are lying. You just don't know it. You're using it all the freaking time. And here's why. It matters anyway. Here's why it matters. You have merge wheres. Every single time that you merge two relations, so when we merge a hash, we know that we're actually going to replace the value on the left-hand side with the value on the right if we have a conflict, right? In our infinite wisdom, we have decided that whenever you merge two relations, if there are two equality conditions, and they happen to be on the same attribute, then since that's impossible, right, a thing can't equal two other things, we go ahead and replace the one on the left with the one on the right. But otherwise, we just add the equality conditions and all the other conditions from the right one to the left one. That becomes a problem in a few cases. It's made my life personally very miserable. I've added rage comments to Squeal, and there's probably been 50 different variations of this method because, I'll get into it. So the point is, we're using merges. We're using merges everywhere. Merges are all over the place, and it gets really, really obnoxious if you actually care about when you're merging. There are so many freaking merges. It makes me crazy, right? There are less now in current 4.0 code, actually, than there used to be. So one key offender that's still doing this today is default scope. How many of you use default scope? How many of you have used default scope? How many of you have regretted using default scope? Right. I want this thing gone. I want this thing gone in the absolute worst way. You're adding implicit behavior that otherwise could be made explicit by actually reading the scopes that you're chaining. And honestly, if you start to read through the ActiveRecord source code, the amount of workarounds that you're going to see just for default scope will make your head spin. So let's take a look at one. You're merging anytime you've ever used default scope because every single time you exec a query against the database, which happens whenever you convert your relation into an array, you're first checking setting the default scope using with default scope. What with default scope does is if you are default scoped, it returns the default scoped version of your relation. If you are not, it returns self. So that's why you have this check here to basically go say, oh, well, if default scope is equal to self, then go ahead and do your thing. But otherwise, actually load the version with the default scope. And here it is doing its thing. You merge inside with default scope if there's a default scope. And then also you're building default scope right in the first step. And that does some merges, maybe bunches of merges. It really depends because you can have multiple default scopes on a model. And that's fun. So anyway, here's some documentation about scope, speaking of scope. It adds a class method, right? And it's supposed to narrow your database query. So scopes narrow your result set. Just kidding. They don't do that at all. Now they do actually in Rails 4, and Rails 4 RC1 anyway. But as of 4.0 beta 1 and anything prior, this is the behavior that you have. You have let's say, a default scope, a Bob's scope, a Tom's scope. And if you chain these things, all you ever get back is the very last one, right? Because we are merging in older code whenever we use these chainable scopes. Every time we chain a scope, we're merging. And so we're getting that last equality wins logic that's so awesome that does things that you don't expect. And so you're not really narrowing your scope at all. So there's this long-standing ticket in GitHub issues. And it explains how this is horrible, right? And it shows some examples. And as of RC1, happy to report that it's better anyway. You can now chain multiple scopes, and you won't find yourself overwriting things. You will, in fact, narrow your result set, except, of course, for default scope, because default scope is a special snowflake. So I would like to see it gone. Honestly, if default scope was not treated as a special snowflake in this case, you would quickly discover that default scope was completely useless, which is why we're treating it specially right now. Calculations are the things that you do with numbers, right? So here's some code. Let's pretend pagination didn't have about 1 billion different solutions that we could use already. Let's say that we want to be able to have a chainable method that's off of a given relation chain that says number of pages, and we can give it a page size, and we want to know how many pages we're going to need to display the results of this query that we're going to execute. OK, great. What's wrong with this code? The problem with this code is that sometimes you might get this message back if you use this method. The reason you'll get this message back if you use this method is because any kind of relation that has a group values will, instead of returning an integer value that represents the count, will instead return a hash of key value pairs and the counts for each. So that's fun. That's a ton of fun. And what you can see here is actually the perform calculation method. Perform calculation does anything from max to min to sum to count, pretty much anything you would do on a aggregation of objects, right? And if there are any group values, we can see here, we execute the group calculation. That method looks like this, and it has extra magic because, magic's awesome. And if the thing that you are grouping on is only one thing, and if it's a string or a symbol, it happens to match a belong to association on the thing that you're now counting, what you do is you find out what the association is, and you hold on to it. And then you go all the way down here. This is all one method, by the way. Did you get all that? I hope you read that. There's going to be a test later. And we create a little lookup dictionary of the key records that matches their ID to the actual ActiveRecord base object that they correspond to. And then down here, we'll actually replace the key with that ActiveRecord base object so that you end up with a hash that has an ActiveRecord base object on the left, and on the value side, how many of that ActiveRecord base object you have. The TLDR version of that is this. I'm not really sure why we don't have a separate method to do this already. Like, if I want a hash, I'll ask you for a hash. Don't do that on my behalf. I would rather get a consistent return value from any method that I call. All right, this is the one I've really been looking forward to. Let's talk a little bit about callbacks. You're going to be sorry if you use them. Trust me on this. And don't say I didn't warn you. How many of you have gotten yourself into callback hell? Yeah, about half the room at least. The rest of you haven't yet. It'll happen. So this is what I like to call a hard sell. This is out of the comments for the callbacks file. We talk about how those 12 callbacks give you immense power. Immense power. It sounds kind of markety, doesn't it? Got a nice ring to it. Immense power you have. So let's take a look at how callbacks are implemented. Hang on to your hats. All right. So you're familiar with before save. We're going to simplify it to just before save. We're not going to deal with arounds. We're not going to deal with afters for now. We're just going to stick with befores. Here are 3 different ways of saying the same thing. We can give it a class, an instance of an object of some kind that actually responds to before save. And before save will get called with the record that is currently being executed. we can give it a symbol. That'll represent a method name on that particular object. We can give it a block. That block will get executed and again be passed a parameter that is the record that we are currently executing the callback chain on. Oh, I forgot one. You can also give a string. For real, you can do this. You shouldn't. According to the documentation, it's deprecated, but it's not. It doesn't issue a deprecation warning at all. We'll look at it in a moment. So, right. So let's take a look at what we have here. The callbacks, the actual callbacks are of a class callback chain, right? So they get stored on an underscore save, because underscore means special, right? Underscore save callbacks has a class of callback chain. It's actually a subclass of array. And if you look at what we're doing whenever we, yeah, it's pretty funny, isn't it? If you look at what we're doing when we compile a callback chain, we start with a few strings. And then we go through, of course, we want to reverse, right, the order of the callback chain because we're going to build things up from the inside out. And we're going to call callback apply on each one of those, passing the string that we are building in as the argument and then modifying it further. Afterwards, we make sure that we return the value, that's the return value, and we join everything with \n and call it a day. Now, here's what apply looks like. And you can see up here, if we haven't halted, as you know, probably in a before save, you can return false, and if you return false, then you'll halt the callback chain. So if we haven't halted and our compiled options match. Compiled options are your if and unless stuff that you add to your callback. We'll get to that in a second. Then we compute the result. Result equals, right? Because we don't want to have any kind of warnings from our interpreter that maybe this is a bad idea. And we assign to the result the value of the filter. We'll get to what filter is in a minute too, right? And then, so that's all the before filter, and then the code that we passed in originally. So you can see how this is going to gradually build up the string. And you can look here, and we have, the after callback's pretty similar. The around is a fun one. It actually defines an extra method, which then goes in and yields to the code that you already have, if in fact you haven't halted. So let's take a look now at the callback class. And when we initialize this callback class, we do two things, right? We set the filter. We call compile filter on the filter that was passed in. So maybe that's a symbol, maybe that's an object, whatever. And we recompile the options. That's that compiled options that we talked about in a minute. Looking at recompile options, this is great. We go through the options if, we compile each one of those individually. We go through the options unless, we compile each of those individually. But of course, we have to tack on a not in front, because that's an unless, right? Yeah. So now let's take a look at compile filter. This is lots of fun, and basically it's all the same stuff we talked about, the different types of things, right? If you do an if or an unless, you can pass in an array, so it'll go through and map all of those various objects. If you have a symbol, you just get the symbol that you passed in right back. Reason being, remember, we're generating a string, you're just making a method call, so that string is the method call, right? Because self is already the object. And if you go down through, you can see proc, it's actually defining a new method with what may as well be a randomly generated name. You actually get incrementally generated IDs for each generated method in this case. You're adding extra methods for every callback that you add, in that particular case, if you use blocks. And then there's the one at the bottom here, which is if you give it an object. And that one's extra awesome fun. Yeah, forget it. I can't go into it. I'm running short on time already. OK, so what you get after all of this from compile on a callback chain is a string that looks like this. And you can see it could be more complex, except I didn't put any ifs or unlesses in. All those trues, if not halted and true, those could be extra fun too with whatever it is that we put in there. So what we get once we actually run these callbacks, oh, by the way, magic, right? This is awesome. If we run these callbacks, what happens is we first have to define a method. So the first time that you instantiate, OK, so we saw earlier when we instantiate a new ActiveRecord instance, we get run callbacks initialize, right? That's why we have to define an after initialize callback to override behavior. So the first time you ever instantiate a new ActiveRecord object, we actually call run callbacks, and we define a brand new method, which of course you can see here. It's helpfully not defining it twice, right? If we already respond to it, we'll dump out of that. But we'll go ahead and set the kind callbacks value to, and basically compile that, and then take that string and throw it in a method and make it protected, right? So that we can't call it without meaning to call it, right? So here's the thing. If you look at the actual implementation of callbacks for the most common operations, right? Save and update and create and so forth. They're pretty simple to understand, right? You have destroy, you have touch, you have create or update, which is where you run your save callbacks. You have create record and update record, which are where you run your create or update callbacks. And there, usefully, we use super, right? Because that's where we should use it. I have a novel idea. There's this thing called inheritance, and I hear that object-oriented languages allow us to do that. So here's a before filter in a sane world. We can define create or update, and we can do the thing that we want to do before the other behavior, and then we can say super. But wait, what if you want to stop and not execute? Well, there's this operator that you can add, and then you won't do it if it's falsy, right? Now, if you want to be a stickler about it, that would still stop on nil. Okay, so check if it's false. That's fine. It's still just Ruby. Here's an after filter. It also works like Ruby works. And you can also back out of an after filter and reverse or revert anything that you do with an ActiveRecord rollback error. And here's an around filter. You do some things, and then you do the other thing, and then you do some final things, right? Now, I don't know about you guys, but this I can understand. And if I can understand it, then I can reason about it. If I can reason about it, then it's less likely to have buggy behaviors or pull douchebag magic on me. We can also do unlesses and ifs, right? Because, again, it's Ruby. So I'd like to rephrase this whole ActiveRecord callbacks documentation. My version of this would be, that's Ruby, which gives you, immense power to do, pretty much anything ever. So why does this matter? People will say, well, ActiveRecord's working well enough. There's no real problem here. It does obviously work for all of us that are using it. Otherwise, we wouldn't still be using it, right? It's big, it's complex, so change is going to be hard. So let's just not bother changing it because it's going to be ugly. And besides, changes are probably going to intentionally break things as we remove things like default scope, right? Changes might accidentally break our stuff, right? Because nobody understands it. I think we've established if you already knew every single thing I've just shown you about ActiveRecord, raise your hand. Right, Aaron. Aaron raises his hand, right? Thank you, Aaron. So, you can also use something else we need. And look, I'm really super psyched about what the Data Mapper team is doing with Data Mapper 2. I think it has a lot of promise. It's taken a long time coming, but they're being really careful about it, and I'm okay with that. But the arguments that I just gave you, I have a secret. I copied them from Wikipedia, and I copied them from an article on legacy systems. And I came to the realization that ActiveRecord is legacy. And I don't mean that in a disparaging way, really, right? Legacy systems become legacy because they work. More importantly, ActiveRecords are legacy. And it's what we're leaving to the next generation of Rails developers. It deserves better. New users deserve better. And I think we can do better. So I want you to go away from this talk and write some docs so that the docs actually match what the behavior is supposed to be. Or maybe write some tests so that I don't break another release of Rails. That would be great. Or triage some issues. There are 230 plus issues right now tagged ActiveRecord, and I can guarantee not all of them are even real issues. If you start to dig in and understand how ActiveRecord works, you'll be better equipped to help reduce that issue count. More importantly, get informed about how it works so that you can participate in the discussion. I'd like better to start now. Thanks.